All right, for this last section, I don't know why it says 4.1. This is not 4.1. 6.7. All right, so projectile motion is the primary application for quadratic functions. Okay, primary application. All right. So, a couple things to know about projectile motion. It is how the height changes as time goes forward. So it creates a parabola, that quadratic graph. Right? They have a couple of commonalities to them, depending on what numbers that you'll see a lot are -16 and -4.9. And that just depends on, are they in imperial, so using like the United States system, or are they metric? Okay, so -16 would be imperial and -4.9 would be metric. It's how gravity affects projectile motion. So some main things, you're going to want to have Desmos out, your graphing calculator, Desmos. All right, we're primarily going to be using that. I'm going to show you the algebra, but we're going to be using Desmos. Okay, so at what height did the object start? All right, this is asking for the y-intercept. Where does the graph cross the y-axis? When did the object reach its maximum height? This is looking for a time. This is the x-coordinate of something called the vertex, and I'll show you what that looks like here in a second. Actually, I'm going to show you right now. It's the peak of the graph. What is the object's height? So it's looking for the actual height there. This is the y-coordinate of the vertex. When did the object reach the when? That means we're looking for a time. This is when the height, so h of t is what we use, height equals 0. If the object has been in the air for a blank amount of seconds, so literally blank seconds, what is its height? Plug in the blank for time. At what time did the object reach blank amount of feet? When that happens, you set it equal to that blank. And you solve. I'm going to show you all of this, okay? So make sure you've got Desmos out, and we'll get to it. All right, a water balloon is launched straight up. A balloon's flight is modeled by the function h of t, so that's the height, equals -16t squared plus 192t, where h of t is the height in feet, and t is in seconds. Use the graph to answer the following questions. So at what height did the water balloon start? Well, that's the y-intercept. So this is my y-axis, and I can see the y-intercept there. Well, the ordered pair down there, 0, 0. So it must mean the height when the water balloon started was 0 feet. Okay, it's like imagine launching it straight up from the ground. Like if you have one of those like catapults, or you know how like kids get really mean about it and pull it like way the heck down. It probably means it started at 0. When did the balloon reach its maximum height? So this is the x of the vertex. So the x of the vertex, this is the vertex. So I'm looking at the ordered pair, specifically at its x-coordinate. So it took 6 seconds to reach the max height. What is the max height? This is the y of the vertex. So I've already used the x, so this is my y. It made it to 576 feet. Okay, same graph. So I'm going to go ahead and just turn the page. It's the same graph. I just didn't have room to do all the questions. When did the balloon hit the ground? This is when the height equals 0. So I have two places where the height equals 0. And that is here and here. So this is where our logic comes in. Launching the balloon. So it's gone up into the air and it's come back down. Okay, does it make sense that it took 0 seconds to go up and come back down? Okay, so this is out. So I'm going to look over at my other x-intercept. Well, its x-coordinate is 12, and I can see that the height, which is the y-coordinate, is 0. So it must have taken 12 seconds to reach the ground. All right, after 3 seconds, is the balloon going up or down? So I'm going to find 3. There's 1, there's 2, there's 3. And kind of like imagine going up. All right, so we're checking whether this graph is increasing or decreasing there. It is increasing, which means the ball is going up. Okay, we can even estimate that time a little bit. So in the middle is 500, and I'm right here. That's 450. I don't know, maybe 425? I'm just estimating. I can't tell really. After 10 seconds, is the ball going up or down? Well, here's 10. So right there. It is decreasing. So the ball is going down. Okay, we can even estimate that height a little bit. That's 300 right there. So maybe a little bit more than 300, like 315. I don't know. We're estimating at that point. Okay. Now, I'm still going to let you use Desmos, but I'm going to show you how to do this without using the graph. Okay. How tall is the building? So the math that we do here is we plug in 0 for t. So ball's thrown off the top of a building. Its flight is modeled by h of t. There's my function. When h of t is in feet and t is in seconds. So I'm going to plug in 0 to each of these t's. All right. Well, negative 16 times 0 squared, that's 0. 96 times 0 is also 0. So the height at 0 seconds is 112 feet. Well, guys, if that's where we launched the balloon from, that means the building is 112 feet tall. When did the ball reach its maximum height? Okay, there's a formula for this. X equals negative b over 2a. Okay, let's talk about where those variables are located. A is the coefficient of your square. B is just your coefficient of x or t. C is your constant. So my b is 96. So negative 96. My a, negative 16. All right, so negative, that's a calculator. Negative 96 divided by negative 32 is 3. So it took 3 seconds to reach max height. Okay, what is the maximum height? That's when we plug in that 3. So every time you see t, you plug in that 3. Again, calculator. Provided I got all my numbers right. I forgot what it was. 256. Yep. The maximum height, 256 feet. When did the ball hit the ground? Now, this one I am going to show you on Desmos. You set it equal to 0. I'm going to hold off on that for a second and show you what that looks like. What is the ball's height after 2 seconds? Okay, so that means we want to plug in. I'm going to show you both of these in Desmos. All right, when you use Desmos, you have to use X's instead of T's. So I've used X's here. Now, what you can see right now is that I cannot see the top of my vertex. I can't see it. So you go over to here to the wrench on the far right, so far upper right corner. And I'm going to change the y-axis. You see where it says positive 9.146 right here. I am first going to try like 500. Okay, that happened to work. I don't need it to be that far, so I can just drag it. Now I can see the whole graph. I like this version better, just so I can see it. To see what I'm asking for, you want to make sure your equation is selected. So it's got to be highlighted. When that happens, you have little tiny faint gray dots that show up. One there, one there, one there, and one there. Okay? Well, at -1, 0, that's an x-intercept. 0 and 112, that's a y-intercept. I'm going up and around. The top, that's your vertex, 3 and 256, which we already got. Back down to 7. So when did the ball hit the ground? So that's when the height was 0. Well, the height is 0 at -1, which doesn't make sense because time can't go backwards. And at 7. That makes sense because time moves forward. It took 7 seconds to reach the ground. What is the ball's height after 2 seconds? Okay, height is an x. So I'm going to open up a new equation and say x equals 2. And again, we have a gray dot that shows up. I'm going to click that gray dot where it hits the parabola. And I see that it's 240 feet. So all of these things I got algebraically, I can get with my graph. How tall is the building? Y-intercept, 112. When did the ball reach its max height? That's your vertex. 3 seconds, and the max height is 256. When did the ball hit the ground? We just did that one, 7 seconds.